without programming, though, robot is nothing but it is a very nice looking and expensive paperweight, because programming is the brain, or it is like uh, we are giving set of instructions or algorithms so that the robot could find the path, or it could find the object, or it can plan itself, or it will come to know what kind of environment it is in actually. So programming helps to understand the robot, and it also makes the robot to do certain tasks. So it is more or like a kid. So if you have a kid, if you have a sibling or any people, so the parents used to command or they used to scold any kids like should not do like this. You should do certain things like only a good way, or it is more or like your parents would be telling you to do something uh, good. Like if you are doing it wrong way, they would guide you to do in the right way. So that's how we are going to do. So we as a roboticist should be more aware, like more aware and understand the robot and its purpose. Because only if we understand the purpose of the robot, we could give the exact commands and exact programming codes to it to make the robot work effectively. So this session will be helping you to get how to get started on and where to learn the programming. So this is more of a beginner session, and I'll just give you a push, or just give you an ignite for learning the programming. So the I'll also show a practical example which will be using the Tinkercad, and it will use code blocks languages for an programming and Arduino. So we will also assume I have also assumed that you will be have a general knowledge about what an microcontroller or what a software is and how to install a software, and you let's assume you have a good knowledge in computer science, like not exactly in depth, but generally how to install a software, and how to open an account in Google, or how to how to integrate or download certain stuffs. So those all are prerequisites that we would be needing to cover this session. So there are actually many programming languages which can be used for programming a microcontroller. So Arduino is first of all an microcontroller. It is the brain part. It is one of the brain part, let's say, because there are many types of boards, development modes, programming boards, but Arduino is the most common one. And we'll be talking more about Arduino because, as I said earlier, it is much easier and the best way to start for the beginners. So assembly language. So starting on with one of the programming languages. So assembly languages is just one step away from a machine code, and it is such a very tedious to use also. So assembly should only be used when you need an absolute instruction level control of your code. It means that you are in total complete control of your code. You can edit it any way you want, and uh, you can pause, and you can also simulate certain programming codes in whatever time or whatever duration you want. So that's the assembly language. And assembly languages are a bit old, and most of the assembly languages are being used in the industries and companies. So next one is a basic level code. So it is one of the first widely used programming languages. It is used by some microcontrollers like Basic Micro, Basic X, Parallax for educational robots. So these are few microcontrollers which are used previously before Arduino showed up. And these are the main purpose of these microcontrollers are the same as Arduino also, but it uses a bit different languages, programming languages, which is called as basic. Oh, next thing, it is actually one of the most popular languages, as you already know, most of them might have heard about it. So in C and C++, we can do very high level of functionality. It means that a high level of coding can be implemented easily in C and C++. So the next one would be the Java. It is a bit more than C because it was lately developed, and it also have more functionality than C, or it is more kind of into software application and web developments. Though it can also be implemented in microcontrollers also. And some manufacturers like Parallax make microcontrollers specifically for the use with Java. So those kind of microcontrollers are also be there. And .NET and C hash, or Microsoft's proprietary language, is used to develop applications in Visual Studio. If you guys have time, please do explore about what Visual Studio is. It is one of the coolest yeah, interface where we can develop a number of stuffs. So examples include NetDino, PhysRhino, and others also. And the next one would be the processing languages, or Arduino. It is actually a variant of C++ that includes some simplifications in order to make the programming far easier, and it also being much speed than the other languages. So the next thing is into the core part. What is an Arduino? So Arduino is a prototype platform, and it is actually an open source. So for people who don't understand what open source is, that open source is nothing but it is an free software or free entity. Actually, the Arduino board, it consists of a circuit board, and which can be programmed, which is referred to as a microcontroller, and ready-made software also available, and it is called as an Arduino IDE. It means Integrated Development Environment. This is actually used to write and upload computer code to the physical board. So that's the integrated development environment. The software does nothing but when we write some code in a computer, it does takes the input from the computer and it transfers to the physical board. I mean the Arduino board. So that's the job of IDE. So Arduino provides a standard form factor that breaks the functions of the microcontroller into more accessible packages. So with Arduino, one can get to know the basics of microcontrollers and sensors very quickly. And they can also start building prototypes with very little investment in it. So because Arduino costs like around 400 to 450, and genuine and more developed Arduino boards are cost between 1,000 also. So I want to mention few of the key features of Arduino board. Arduino boards are able to read analog and digital input signal from different sensors. The analog signal and digital input signals are the basics of electronics. And when you get to start learning electronics in your engineering, you will get a clear understanding about it. And meanwhile, I'll show a bit of simulation in Tinkercad, and I'll explain what analog and digital signal means. And it turn out into an output such as an activating motor, turning LED on and off, connecting to cloud, and many other actions. So these all are different stuffs which could be done using an Arduino board. So you can control your board function by sending a set of instructions to the microcontroller on the board via Arduino IDE. So like I said earlier, board functions are nothing but couple of instructions or programming or code, or even you could say as a command which you could give to the microcontroller in Arduino. So the next feature is like it is unlike most previous programmable circuit boards. Arduino does not need any kind of extra piece of hardware, which is called as a programmer, because most of the boards, circuit boards, have a separate programmer or microcontroller which is attached to an circuit board. But in this case, Arduino board comes along with a microcontroller, and it contains every kind of circuits in it. Like I said in the first point, can do a number of functions using this board. So in order to load a new code onto Arduino board, you can simply use a USB cable. And I did not brought the USB cable now. Yeah, but I have attached few pictures you could understand in the later slides. So additionally, the Arduino IDE is a simplified version of C++, making it easier to learn programs. So any programming languages or any programmers would start their programming language on with C or C++. It's like the godfather, or people used to call it as a mother of programming languages. So C or C++ are much easier to learn, and it is like once we have learned C or C++, you can learn any other programming languages so easily. You could understand any kind of languages easily. And finally, Arduino provides standard form factor that breaks the functions of microcontroller into more accessible packages. So this is a bit complicated, like it provides many packages, and for each function, it contains certain functions. So these are few common types of Arduino boards. So various kinds of Arduino boards are available depending on different microcontrollers used in it. So, however, all Arduino boards have one thing in common. They all being programmed through Arduino IDE, the integrated development environment. So the differences are based on number of inputs and outputs. I mean, the number of sensors, LEDs, buttons that you can be using in a single board. And few of the differences are also speed and the operating voltages, form factors, and etc. So some boards are designed to be embedded and have no programming interfaces also, which you would need to buy separately. So some can run directly from a 3.7 voltage battery, and others they need at least 5 volts of input. That's a few differences between these board apart from the Tableau column details which I have mentioned. So as you could see in the Tableau column, clock speed is nothing but the speed of the microcontroller and the ticking. So every controllers have this clock speed. Like even in your own laptop or system, you have something called clock speed in your processor. So it's nothing but the processing speed. And digital input and analog inputs are nothing but the pins, number of pins available in the Arduino board. So let me just show you. As you could see in this video, there are several holes in the strips. I mean, the hole strips in the board. So these are the different pins that are available in this Arduino board. So in the next slide, I'll be explaining about it. So just hold on if you guys have any doubt. So PWM is pitch width module. So this is the pitch width module is a signal type, and in this session I did not cover it about the PWM because this is more to a basic level, and I don't want to get into more into electronics also. So if you guys have interested, please do make a note of it and kindly search about how PWM differs and how it works. Okay, so programming interface is nothing but the which are the stuff or extra things that would you would need for programming from the laptop or your from your computer to the Arduino board. So as you would see in the picture, you need USB via 80 mega 16U2. It is nothing but the processor, and few does not as I said earlier, few boards does not need any kind of programming interface than USB. Like Arduino Mega 2560 R3 version does not need any kind of microcontroller on extra hardware for interface. So here is a picture of the bunch of Arduino boards. These are different types of boards. As you could see, the right top corner, it is a nano, and it is a few boards are coming like, sorry, this is a micro, and this is a nano, and this is Uno, and this is a zero board. And here the bigger one is the Arduino Mega. So these are different kinds of board. It totally depends on what's your purpose and what's the need of a microcontroller on what type of microcontroller that would be needing for your robot or for your experiment. So here are the components of Arduino board, as many guys would have waited for this, like because Arduino board you have seen, and you also have went through what how it works and what kind of purpose that does it have. Now let's see about what are the things that we can do in Arduino physically. So power USB. So the first part would be the power USB. So Arduino board can be powered using the USB cable itself, and from directly attaching it to your computer or from your laptop. All you need is to connect a USB cable to the USB connection one. As you could see in the image, this is the USB port, or I'll show you in the video itself. So here is the USB board, sorry, USB port. As you could see here, this is a top view and this is the side view of USB port. And the next thing is the power jack. So I mean the barrel jack. So Arduino boards can be powered directly from the AC main power supply by connecting it to the barrel jack. Barrel jack is nothing but the number two in the image, and this is the barrel jack. And this is where you can power the Arduino directly from the AC power supply. And the next thing is the voltage regulator. So the function of voltage regulator is to control the voltage given to the Arduino board, and it is also used for stabilizing the DC voltages by the it is used by the processor and other elements. It is nothing but you could see in the image the third one, the bit tiny one, that is voltage regulator here. As you could see here, this is a voltage regulator, and nothing else. It supplies the voltage correctly to the microcontroller. Or let me show you. So this part here is the 80 mega, and it is a microcontroller. So voltage regulator does nothing but whatever the input voltage to the microcontroller, it just divides and supplies properly to the microcontroller and other elements in the board. So the fourth is the crystal. Actually, the fourth is a pins, and in the image, the fourth is the crystal oscillator, and it does have a bit complicated function. I don't want to mention about it, but it is not much needed for a basic level. And let me continue with the pins. So as you could see in the image and the slide, 3.35 and the ground V in, these are the small pins that are available for the power supply. I mean the output and input port. So as you could see, 3.3 is nothing but 3.3 voltage, and it is for the supply of 3.3 output volt, and 5 is for 5V is for 5 voltage. And most of the components used with the Arduino boards work fine with 3.3 voltage and 5 voltage. And you could also see a ground, and you can also see a V in. V in is nothing but the pin which can be used to power the Arduino board from an external power source like AC power supply, apart from the power barrel and USB port. So that's the positive and negative pin that are available in the Arduino Uno. And there are also the few other pins, analog pins, as you could see over here. Okay, I'll change the image. I mean slide. As you could see here, there are something called as A0, A1, A2, A3 until A5. So the Arduino Uno board has almost a 6 analog inputs from A0 to A5. These pins can read the signals from analog sensors like humidity sensor or temperature sensor and can convert it into digital value that can be read by the microprocessor. So here we need to make a note that Arduino reads any kind of analog signal and digital signal. But if a few sensors supply or the few sensors output would be analog only. So those kind of analog signals are being taken from these pins A0, A1, A2, A3 for A5, and it converts the analog signal into an digital signal so that the microprocessor can read it properly. So the main controller is the point 11, which is shown in the image, and you can assume that this is the brain part of the board. So the main integrated circuit of the Arduino is slightly different from board to board. As I mentioned in the here, this tabular column, few works with fine with 80 mega, what you called as 3 to 8P, and few have different kind of microcontroller attached to it. So it is completely differ from a board to board. So the microcontrollers are usually the from ATMEL company. So that's the company who generally makes the microcontrollers at the best level. So you must know what IC your board has before loading a new program from Arduino IDE. So this information is available on the top of the IC circuit, which is in the board. And this information is available, for more details about the IC construction and functions, you can refer the data sheet of Arduino, which is available in internet. And as it is open source, you can access it anytime for further investigation about this. And power LED, this LED you should light up when you plug your Arduino into a power source to indicate that your board is powered up correctly. If this light does not turn on, there is something wrong with your connection. You need to check it out with the feedback from LED. And then comes up the TX and RX LED. These are a bit important. So on your board, you will find two labels, TX and RX, which means a transmit signal and receiver signal. They appear in two places in Arduino board. First, the digital pin 0 and 1 to indicate the pin's response from the for serial communication. Second, the TX RX LED, which is mentioned in the 13th here, and the TX LED flashes with different speed while sending the serial data. The speed of flashing depends upon the baud rate and used by the board, and RX flashes during the receiving process. And let me show in the video once again. So as you could see here, I hope this is a bit clear or not clear. Anyways, so in this board, you could see the TX and RX pin are available over here. So this blinks when an power supply, when the data transfer happens from the computer to your board. And digital input is nothing but the Arduino board, has 14 digital input pins. So previously we discussed about the Arduino pins from A0 to A5. Now let's look into the digital inputs. Like it have 14 pins, actually 15 in total. In the 15th point referred to it, of which 6 pins are for pulse width modulation. And as I mentioned in the previous slide, in the difference of board, pulse width modulation output varies from board to board. So these pins can be configured to work as an input digital pins to read the logic values zeros and ones. So as digital output pins to drive different modules like LEDs, relays, motor trials, and these pins are generally labeled with a tilde, which can be used to generate pulse width modulation. So as I said earlier, here is the two cables which are available. So you need to find the right cable you need. Sometimes when you buy the Arduino board, the cable comes with it, so that you won't buy a different one. So as you could see in the image, this thing is used for Arduino Uno, and this cable is used for Arduino Nano. So these are generally common boards which we can use for a beginner. So I have mentioned these two only. So as you could see in the image which we have shown in the bottom, it is like we can download the Arduino from their official pay website itself. It is free, of course, since I mentioned it is an open source, and you can download the Arduino software and you can install it. And the third step would be powering up your Arduino. So the USB connection is much enough for USB connection from your computer is much enough for powering up your Arduino Uno. And the thing is, like, connect the Arduino board to your computer using the USB cable so that the green power LED should glow in your Arduino board. So once you have connected the board to your system, there will be an green LED which will be glowing up in the in your Uno board, and that would be an indication where the Uno is being properly connected to it. So let's start with the structure. So software structure consists of two main functions: setup function and loop function. As you could see in the image, setup and loop are the two main structure of programming an Arduino board. So inside void setup, you could give the purpose of your board, I mean your purpose of the command or purpose of the code, and that's where the setup function is first called when the sketch starts. So use it to initialize the variables, pin modes, start using the libraries, functions, etc. So the setup function will only run once, and after each power up or reset of the board. And you can also give inputs, outputs, return values in it. And inside the void loop, after creating the setup function, which initialize and sets the initial values, the loop function does precisely what its name suggests. And loops consecutively, allowing your program to change and respond to it. So use it actively to control the Arduino board. And even in the void loop, you can use any kind of functions and inputs, outputs. And it the function of void loop is generally that it not only run once, it is an loop function, and it goes on until you give an encode. So here we can create 3D designs and circuit boards and a few code blocks also, and a few inbuilt lessons are also being provided here. And th this is not like I have not started any kind of lessons, and you can access this classroom, I mean classes for many tutorials using Autodesk Tinkercad. Okay, now as of now, let's move on to this. And these are few experiments which I have done earlier. So click before starting on it. Don't forget to sign in using your account, any kind of Gmail, email accounts for into this Tinkercad. So Tinkercad is nothing but an kind of IDE which is totally online, and it is much more easier for beginners, and even for intermediate level we can use it to a far end. So let me show you few examples, and in future actually I plan to create many other experiments using Tinkercad, and I'll be uploading it very soon. By next week, probably I'll be uploading it. So as it mentioned, we can discover many pre-made circuits for starters to begin with. So once you are inside the new circuit design, you can click on the right tab and go on for, you can explore whatever things you can do in this. Anyways, I'll just concentrate on Arduino because that's the scope of this session, and also it is being late already. So I have clicked the Arduino, and here there are many types of connections using different types of sensors, and they have also used various kinds of codings in it. So let me start on with the very easy and simple one. Let me go for the Blink project. Once you can click it, or you can even click and drag to your the board. You can see it as a working board. So as you could see here, this is an resistor, and this is an LED, and this is the Arduino Uno board. So simulations are far better and most suggestible way of doing your experiments and learning stuff, because if you're buying an Arduino Uno and you're directly connecting it with few components, it could burn up or damage it for the first time if you're doing it, because I have already experienced and I have burned few boards also. So I would really suggest you guys to do first the simulation, and you just copy it and do in the real life. So that would be much safe for the your board and for yourself also. So this is the most cost effective way. And when you connect an LED, you should also always have an resistor. And this LED is you can actually not only as a kit you can explore more in this, and you can add more other stuff if you want, or more other components if you want, than and simple LED. So as of now I have concentrated only in this. Let me just move on to the coding stuff. And before that I want to mention that here, look at this connection. Actually LEDs do not give any kind of analog signals, and we no need to connect it with the analog. Since LEDs give out digital signals that is either 0 or 1, it is being connected to the pin 13. So, and there is no constraint that you should connect only in the pin 13 or pin 12, but the negative, I mean, the signal wire can be put on into any kind of pins that you want. So this is here, this is how you can disconnect few components and you can move along the your board for your convenience. So let it be in the 13 as of now. And the resistor values they have given as a 220 as a predefined. You can change it to 100 ohms or anything. For it totally depends on your experimental values. So I have just changed for a few because I'm a bit bored. So here is a code tab and just click on it. And here comes the predefined, or they have already provided you how the blinking experiment works. This is nothing but the title block, or you can, I think I assume that you have already explored what code blocks are about. You can just click and drag. So before using a code block or programming language, one coding before starting coding, basically you should have an algorithm. Algorithm is nothing but I have mentioned this in the third session. I think so. Algorithms are nothing but set of instructions and a set of steps that you need to take one by one. So before moving on here, I'm just show you like how it is going to be done, because these command blocks as of now you don't need to consider about it. Only the blue and I would say what kind of color is this? So okay, it's kind of orange. So it's a mixture of orange and yellow. So these two colors are the main part which we need to concentrate as of now. So command blocks are nothing but for your understanding they have given it. So as you could see here, output, input, notation for the commands and variables can also be created here, and few predefined math functions are also given. And for control in the sense, the loops and the condition statements are available in the controls option. So first we need to give output, and that's where they have given the set in built-in LED, and the LED can be high or low. Two options are also given. And here they have given the LED should wait for 1 second. I can give it as I can change the values for 3 seconds, and I don't need these command blocks, and okay, let it be there. So the set in build to low is nothing but we can set the LED, like this is high means on and low means off. That's it. And for the waiting seconds of after off is 0. And generally when we give these kinds of command, it comes and the output command always comes inside a loop. So as I mentioned earlier, void setup and void loop functions, this comes under void loop. Okay, now let me show you another thing how it is being implemented in text. So when you go into block plus text option, it clearly shows you the Arduino programming. And that's the shortcut which you can do if you are a beginner. So if you don't have any kind of knowledge in programming languages or the Arduino programming, you can start on with block. So you just have a algorithm or a plan that how the experiment is going to be, and you can just click and drag the code blocks over here, and this will convert the your code blocks into the Arduino language. As you could see here, the white setup is the pin mode 13 because I have put on the LED to the 13th pin. And if you are changing the pin, it automatically changes here also. And these commands are nothing but uh, the command box have transferred it into the command section. And moving on to void loop. So void loop is, as I mentioned earlier, here we can do the main functionality of your experiment. So we have mentioned as LED high, and that's the code which have been transferred here. And wait for 3 seconds have been transferred to wait for 300 3000 milliseconds, because In general, Arduino programming, the delay or the seconds are being transferred or considered as milliseconds. So whatever thing which you could give, you could also change over here as a 3 millisecond, because that's not a possible. So we can change it as 3000 milliseconds. That would be more logical. And again, the command box, if you're changing here has an turn of code, so that will be reflected over here. And that's the transformation which we could see there, and from code blocks to Arduino. So now you have created this. And as I said earlier, you can also add more functions. And before moving on, I'll just show you about it also. I have just assumed that I'm having a servo attached to a motor, sorry, to the Arduino. So when I attach this code over here, there's a new function or new code which have been popped up here. This is called as an hash include servo and servo underscore zero. It means that it automatically adds the necessary package that would be needed for this program, for the Arduino program. So for speaker also, it will be changing on. I'm just adding senselessly. Don't consider this. I'm just want to show how it changes. So when I put the turn of speaker code block here, and there is a change over here. So you could just give variety of pin, and it could be reflected as the codes over here. So that's how easy a coding can be done here. I'm just showing you a few examples. So done. So here is a bit of codes which could be implemented using code blocks and Arduino languages. So once you completed with this, the thing is like we can download this code in the Arduino form itself, and they have been given an option for downloading this code over here. And since I have used Arduino Uno already here, it has been showing as Uno R3 coding languages here. If you use any other microcontroller, it will change according to it. So I'm clicking on the download code now, and yes, it have been downloaded. And as you could see in the screen of my screen, it is .ino form. So .ino form is nothing but the Arduino programming form. So I'll just open it for you guys, and I'll share that screen also with you for better understanding. So I have already installed the Arduino IDE, and just wait for a couple of seconds. It's being loaded now. It takes quite a bit of time to start. So once you have completed with this programming stuff, you could directly implement the same to your real life programming experiments. Okay, now it has been opened. I hope you could see the screen of Arduino IDE. This is how an IDE looks like. And here is the code which I have implemented in Tinkercad, and it has been downloaded and directly being printed over in the IDE. I mean, because I downloaded it in the .ino form so that it could be easily opened directly. So now that once you have downloaded this code, you should verify whether it is correct or not. Since I have given unnecessary few codes, I would delete it. Okay, and servers also. So I don't need this. So here is the example code, and this is also not needed. So you could verify whether this code is correct or not by clicking verify, and it will take a couple of seconds to compile, and it will show you whether it has any compilation error or not. Okay, I don't know. Today, before doing this, you could also change the name of your code before downloading from Tinkercad. So yes, done compiling, and it does not have any kind of error. and it also shows how much of bytes it could take in your storage space. And this is just the terms of bytes. And once if you have connect, I did not connect it to the Arduino board because I lost my cable or I have kept it in my lab. So after compiling, you need to upload it to the Uno board. So go to tools, and in the under the board section, you would get to know what are the different kinds of Arduino boards are available. And I have chosen Arduino Uno. And next step would be you should also choose the port connection, which I have mentioned in the previous slides. And since I have not connected to the laptop, it is not showing. And if you have connected, you choose which port that your Arduino is being connected. I mean, the ports available in your system and a laptop. And you once you have selected that, also it is done. And you can click upload for uploading it directly to the board. And now it won't upload because I did not connect it.